Questions for Unit FM Activity 5. So for number 1, I put when a single force acts on an object, the rate of speed changes and affects the cart by causing it to move faster or slower. No matter the strength, any type of force affects the object. It works for both increasing and decreasing in speed. The graphs in this activity are examples of this statement, and especially the one with the cart moving the fan on it and receiving an initial push when moving. The cart having the fan, sorry. Wasn't sure what I put right there. So that's number 1. And then for number 2, when we were trying to describe the graph, I put the initial force of the quick push was the stronger of the two forces on the cart. I believe it's the stronger force because of how steep the initial slope is. Shows that the cart received a high rate of change of speed with the force of the initial push. And then for number 3, I put the mass of an object changes the rate of speed because depending on the mass, may need a strong force to move forward or a weak force may be able to move it. The experiment with the weight on the cart showed how with a low mass the rate of change was high while the cart with the heavy mass had a low rate of change of speed and moved slower than the other cart. And then for number 5 on who I agreed with, I agreed with Han. Amara says that the more mass an object has, the faster it slows down, which is not at all true. From the experiment, we saw the carts with weights on them. The one with less mass quickly stopped and backed up, while the heavy mass cart took a while to pause or move forward in general. In the activities, we knew the mass itself and amount of force, so to figure out a rate of change, we had graphs. That was how we figured out. We didn't really have a equation. I like Han's equation, and I kind of used it eventually. I think that seems correct to me. Multiplying it would not find the rate, it would find the total. So I think his equation of dividing it would find the rate, which is basically like finding the average. So in number 6, I actually used that equation a little bit because I don't know, to me it worked. I put if we use the equation from the previous page, the rate of change, cart A's rate of change is 0.6 milliseconds per second, and cart B's rate of change is 0.5 meters per second. And I think that cart A will win the race because not only is it the lower mass cart, but also has a pretty high rate of change of speed. There's only a 0.3 difference from cart B. In general, cart A has a lower mass, which already increases the rate of change of speed, and it has a closer the amount of force behind it is not there's not a huge difference between cart A and cart B. So they basically have the same amount of force, and yet cart A is lighter, so that's why I think cart A will win. And those are my answers.